Let's take more examples on set builder form. Okay. Suppose there is set given to you. Let's say set B is given to you. It is 1 by 2, comma 2 by 3, comma 3 by 4, comma 4 by 5, comma 5 by 6, comma 6 by 7. Suppose there is a set given to you which has element 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, comma 6 by 7. Okay, these are the element of set B. Now, what we have to do, we have to write the set builder form for the given roster form. Okay. Now, now the logic is simple here. We have to find a rule which follows every element of the set. Okay, which is followed by every element of the set. Now, here we can see uh, it is 1 by 2 and it is 2 by 3, 3 by 4. Okay, look at every element. If you see, if you add 1 in the numerator, we will get denominator. Okay. Now add 1 in the numerator, we get denominator. 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 It satisfies every element is satisfied by this rule. Okay. Now what we will do, we will formulate this logic. Okay. Now let's say I represent mm, n by the I represent n as a numerator. Okay, then what will be the denominator? Denominator will be added by 1. Okay, now denominator will be n plus 1. Okay, if a numerator is n, if numerator is n, denominator is numerator plus 1. Okay, so numerator is 1, so denominator will be equals to numerator plus 1. So that is the rule. So we will write this in the set builder form. So set B will be equals to x is element of B such that this x is equals to n divided by n plus 1. Okay. Now this is simple. Now what you have to do, uh, this is not enough. Okay, this is not enough. We have to complete this. Okay, because there is some restriction. Because maximum denominator goes up to 7. Okay, not more than 7, and maximum numerator goes up to 6, not more than 6. Similarly, maximum numerator, so minimum numerator goes up to 1, not beyond that. Okay. Now, how we will write this? First of all, see this, that every element is a numerator and denominator, which is numerator and denominator, which is a natural number. Okay, so we have to mention that in the set builder form. So I have taken n in the numerator, so I have to mention that n will be a natural number. So n is a natural number, and we have to also mention that n maximum goes up to n is a numerator. So numerator maximum goes up to 6, and numerator is minimum up to 1. It cannot be less than 1. Okay, so we have to mention that small letter n is less than or equal to 6 and greater than or equal to 1. Okay, this is the complete set builder form. Okay, now let me explain again that. You can see in every element that if you add 1 in the numerator, we will get denominator. Okay, so if numerator is n, denominator will be n plus 1. Okay, so this is the formula for every element in the set. Okay, so I have represented every element by x, so x will be equal to n by n plus 1, given that n should be a natural number, and given that n should be less than or equal to 6 and greater than or equal to 1. This must be this condition must be there in the separator form, otherwise the set will be infinite. The set will have infinite number of elements if this condition is not there. Okay, but we have limited number of elements, so we have to put this condition to make a finite set, to make a finite number of element in the set. Okay, now we will move on to the next example. Okay, let's go to the next example. Let there be set C which has element 2, 4, 8, 16. Okay. Now this is a set that has element 2, 4, 8, 16. Okay. Only 4 elements are there in the set. Now what we have to do, we have to formulate this element of the set. Now look at the elements, you can see that this can be written as 2 power 1, this can be written as 2 power 2, and this can be written as 2 power 3, and this can be written as 2 power 4. Okay, means if we change the power, if we change the power, and if we make the base same in every in every element, that is 2. If we keep the base 2 and if we keep the power as n, that will be the formula. Okay, so we can write this as 2 power n. Okay, we have kept the base because in all the elements base are same, 2 2 2 2. Okay, but what is varying? Varying is the power. Okay, so we have used n in place of power. Okay, and we have kept the base as 2. Okay, so every element is in the form of 2 power n. Okay, now now we will write this. C is the set, and let M be the element of set C. We can use any variable here. Okay, we can use any variable here. Now M be the element of set C. M equals to such that M equals to 2 power n. Okay, this is the rule. This is the condition because this is the property that every element follows. Okay, now we have to mention what is n. N is the natural number. Okay, n is a natural number. We can see here n is a natural number, and also that n is a less than n is less than 5. Okay, because it n maximum goes up to 4. N maximum goes up to 4, not beyond 4. Okay, so our we have formulated every element in terms of 2 power n, and we have given the restriction that n should be natural number and n should be less than 5. Okay, this is the restriction. Now this is the complete set beta form for the given set. Okay, next we will see some other examples. Let's say there is set D. Now set D has element 2, 4, 6, and 2, 4, 6, 8, 10. Okay, up to 10. So we can in two ways we can write this set into set builder form. How can we write this? Let's say set D. Now let x be the element of D such that x is a even number. X is an even number. Because x is the element of D, and we can see every element of D is an even number. So we have to write x is an even number. Okay, you have to write x is an even number, and you can see all the even numbers are uh, natural number. So we have to mention that even natural number, and we can see that every even number is less than 11. Okay, natural that whichever element is given to you, it is not more than 11. It is less than 11. Okay. So we have to mention that x is you can write that less than 11. Okay, we can write it in the form like this. Now we can this is one way of writing. Okay, we can write this in another way also. So we know that every element is an even number in the set. Now every even number is a multiple of 2. Okay, is that correct? Every even number is a multiple of 2. So we can say that 2 is 2 into 1. This 4 is 2 into 2. And this 6 is 2 into 3. And this 8 is 2 into 4. And this 10 is 2 into 5. Okay. So this is actually multiple of 2. So we will formulate this pattern into in terms of 2n. We can rewrite this in terms of 2n. So what is changing here? This number is changing. Okay, what is changing? This number is changing. Okay, so we have used n in place of that number, and this number is constant. So we have kept that as it is. Okay, so every element is multiple of 2. Multiple of 2, that means it is 2 into n. Okay, 2 times n. Okay, so we will use this one in simple form. Okay, now x is an element of D such that x is equals to 2n because every element is in the form of 2n. Okay, and we have to mention what is n. N is a natural number. N is a natural number. We can see here n is a natural number. Every n is a natural number, and also n is less than 6. Okay, and also we can write that n is less than 6. Next example we will take. Similarly, there is another example. Now set has element 5, 25, 125, and 625. These four elements are present in the set. Okay. Now see what is the property. See, now every element can be rewritten as, this can be written as 5 power 1. This can be rewritten as 5 power 2 means 5 power 2 is 25. This can be rewritten as 5 power 3. 5 power 3 is 125, which is 5 into 5 into 5, and 5 power 4 is 625. Okay. Now, now we can formulate this as 5 power 1, 5 power n. Okay. So E is the set and x is the element of E such that x is equals to 5 power n. Okay. Now see properly here, n value is up to 4 and n is a natural number because 1, 2, 3, 4 are natural number. So n is a natural number and n is less than 5. Okay. We can write this. So this is a set builder form for the given set. Now I want to mention one thing. I want to mention one thing that in set, suppose in question it is given to you, write the roster form of the given set. What is the set? Set of all the letters of word better. Okay. Now suppose this is the question given to you. Question. This is not the question. This is set. Question is write the given set into roster form. Okay. We have given this condition. This is basically a set builder form. Okay, set builder form means a relation is given. Okay, not relation. It is not relation. Property is given. Okay, because a set contains all the letters of the word better. Okay, that means there is a set that contains some letters. Okay, and those letters are from the word better. Okay, now we have to write this in the roster form. So while writing the roster form, do not repeat the elements. Okay, that is a condition in the set that we do not repeat elements. Okay, so if we write a set, it will be B E T R. Okay. Do not repeat the elements in the set. That is the rule we follow in set, that we should not repeat the element in the set. All the elements in the set are distinct. They are not repeated. Okay. Okay. This is it for the uh, topic roster form and the set builder form. Next we'll move on to empty set, and then we'll move on to type of set that we will cover in the next video. Okay, so for this video, this is it. Thank you.